Sure. Do you want me to share screen now?
Yeah, if you want. So let me open.
I cannot. You're right.
Okay, now you can do it. Okay, guys. So today we are very glad to have a guest speaker, Dr. Chen Feng from New York University. So Dr. Chen Feng is an assistant professor in civil engineering as well as mechanical and aerospace engineering. So he is actually a very famous researcher in our area and focusing on automation and robotic technology. And I know his work, very impressive work. So he will be introducing the general automation and robotic technologies for the construction, engineering, and management area. So I will leave all the self-introduction to Dr. Feng. So your turn.
Thanks a lot. Thank you, Eric, for inviting me to deliver this guest lecture. And good afternoon, everyone. My name is Chen Feng, and I think Eric already introduced me. So just a few words about my background. As you can see, I have a pretty complex background. I'm almost always changing my majors. And that is simply because my past research and study was not guided by a single domain. I want to solve problems, and when I figure out I need to use this technology, I dive into that area and learn, and then coming back to see how can I use what I learned to solve the issues that I am interested in. Um, very briefly, so right now I'm an assistant professor jointly between the two departments, and also I'm affiliated with the computer science and engineering department at NYU also. Before joining NYU, I spent 3 years after my PhD in a industry research lab called Mitsubishi Electric Research Lab in Boston as a research scientist, focusing on studying and investigating new computer vision and deep learning technologies, which later on we found is quite useful for civil engineering and mechanical engineering applications. So today, hopefully, I can share some of those stories, and I hope that can give you some inspirations. A few words about my lab. So at NYU, I am directing a lab named AI Force, standing for Automation and Intelligence for civil engineering. The aim of this lab is to advance the robot vision and machine learning via multidisciplinary user-inspired research originated from civil and mechanical engineering domains. So we start from problems that we see in the current civil and mechanical areas, and then we try to abstract the fundamental computational algorithmic problems from those problems, and then try to develop innovative solutions in the computational and algorithmic area, and then use it apply them back to the original problem domain. This completes the circle, and we believe it's beneficial for both the civil and also the computational domains as well. Let's get started. So today I want to give everybody an introduction about the area that I am working on, called Automation and Robotics in Construction. So during the whole lecture, I want to share multiple different views, different perspectives of the industry and the related technologies. And this is that view I think is quite interesting, this image. Before I start, does anyone want to guess where this is and when it was?
It must be
Where
Empire State Building.
Any other guesses?
New York.
Empire State Building.
Right. When? How many years ago, roughly?
Something around 1900 or 1910.
Right. So basically, this is nearly 90 years ago. And it's not the Empire Building. It's the Rockefeller Center. It's the GE building in the Rockefeller Center in Manhattan. And you see these steel workers are sitting almost 900 feet above the ground. They were having their lunches. So this was a very famous photo from the past, and it represents for quite a long time people's impression about the construction industry. So this is a more science fiction perspective. I myself is a big science fiction fan. So one day I saw this photo on the internet and immediately captured my attention because of the obvious connection between the famous construction photo we just saw, right? So what it's depicting here is a bunch of robots. We don't know where it is. Maybe it's a extraterrestrial. Maybe it's in Mars. I don't know. 200 years later. This represents some quite romantic science fiction perspective of how people think in the future. I mean, of course, it's to a direct connection with the old photo. In the future, we may not even need to use a humanoid robot to do all the construction automation work, but at least it is, I think it's a pretty nice view to start our more detailed, technical oriented presentation today. So this view is actually, even though it's still also futuristic, but it will be more realistic compared to the science fiction view that we just saw. This is from the Autodesk company. I believe everyone in this class must have used some of Autodesk softwares before. This is from their blog. It represents how the leader in the industry perceives the future of this industry would be. So if you look at this image, it contains quite a lot of information that we will discuss today, like a robot on a job site, drones monitoring the progress of the job site, and we have all the wearables for the construction crews to acquire information and make them more easily adapt to the environment and acquire information in the context to help them become more efficient. Of course, in the future, all the documents will be automated and connected and shared between multiple stakeholders of a complex construction project. Our construction equipment will be more autonomous, featured by this robot, actually. So how do we achieve all these dreams that we have, these nice dreams we have about the industry, to modernize it so people no longer consider this industry as the GE building image shows, right? So this is, I consider that as one of the most important mission in my lab. Of course, to go from the current state of the technology to this futuristic view, it needs a lot of steps. So in the next slides, I'm visualizing using videos some of the technologies that has been developed in my lab or by myself previously. I number them. For each video, I gave it a number. So the intention is to do a poll, and from the audience, whoever, if you're interested in one of the video, just either shout out the number or you can type it in the chat. And then I can give you more explanation, like a brief explanation of what that is and how would that connect to what we're discussing today. Cool, I see the first number is number 7. This is the first time that I do this presentation where someone picks number 7 instead of number 3. That's great. So number 7, oh, I don't know why it's not playing. Number 7 was my PhD, a part of my PhD research, where we're trying to connect the algorithmic design by architects directly to automated construction. So this was done 6 years ago, actually 7 years ago, and it won a Best Paper Award in the ISARC conference, the International Symposium on Automation and Robotics for construction. So the idea is in the design industry, you see now more and more automatic, fully automatic designs, algorithmic designs. And you have, maybe you have learned the Dynamo, which is one of the software that represents this direction. In the architecture, so in this work I was collaborating with a master's student and a professor at the architecture and urban planning department in University of Michigan. They were using something called Grasshopper with Rhino to do the algorithmic design. So the whole design of a curved wall is fully automatic. Now, if you have this large, you can easily change your design. What we were aiming to do is, can we also connect that automatically generated design to a robot? And we mount cameras to a robot arm and investigate the possibility of performing automated construction from the automated generated design. Okay, this was 6 years ago, and we were one of the first group who did this. And later on, groups at ETH. Later on, I will show a video, and you will see. Hopefully, you will see something similar. I think that was done maybe 2 years later after this work. They took inspiration from this project and scaled it up to something even more fancier. At that time, I was just a PhD student. We did not have enough resources to see everything is pretty simplified, but it was able to show the idea that everything is automatically done by this 7 degree of freedom robot arm. So this is about number 7. I think another number I saw is number 6. Number 6 was actually, I think what this was done when I just started my PhD research almost 10 years ago. Obviously, I think everybody can see this. What I'm doing here is augmented reality. And this is 10 years ago when augmented reality was still just beginning to capture attention in the civil and construction industry. So I was developing a technology that allowed us to show augmented reality, using augmented reality to show virtual building models on the mobile platform. That was 10 years ago. Now you can easily do this with the industry, some of the softwares provided in the industry, such as the Qualcomm SDK. I see a number 2. Number 2 is the recent work that was published last year. It was done 2 years ago. The idea is for a robot to move in a built or even construction environment. In order for the robot to localize itself, you need to first create a map of this environment, or creating a map while exploring this environment. One of the way is to use LiDAR sensor, which we will also discuss in today's lecture. But the robot is moving. So how do we take the point clouds scanned by the LiDAR at different locations and assemble them back into a global coordinate frame? Usually, this process requires manual tuning or requires people to install some markers like sphere markers or planar markers in the environment, and then manually together with the computer to do the registration. This process is called registration. What we did in number 2 is a method that utilized the state-of-the-art. Actually, we developed a state-of-the-art AI-based solution using deep neural network to automatically align the point cloud. So we just input all the point cloud scanned by the LiDAR, and the network will automatically figure out the correct way to align them into a joint coordinate frame without any human intervention. So that can save a lot of labor because you need to install markers or you need to have someone to roughly align. So any other numbers? Let me see. So someone mentioned number 5. Number 5 is a work that called PhotoNet. We developed, I think, 3 or 4 years ago. It is to teach a AI to learn to group different 3D shapes represented by a bunch of points. We call them as point cloud. So in this work, we teach AI to automatically learn to group 3D shapes of the same semantic meaning into a cluster. Right? So the shape of a chair will all be grouped into a cluster. The shape of a table will be grouped into another cluster. And the key novelty here is we did this without any labeling, meaning we're just giving the AI a bunch of 3D point clouds, and and without any labeling. The AI does not know which one is which. And then the key to realize this is to teach the neural network to automatically fold a piece of paper onto a 3D shape. And during this process, the network automatically learns that in order to fold a piece of paper onto a chair-shaped object, the procedure is different than folding it into a table versus into other objects. So this technology is then applied to number 8, which we published this year. To connect it, we use it in soft robotics. Soft robotics means a robot made by soft materials, non-rigid materials. So imagine in the future when we have robots working with humans, we don't want them to be, maybe we don't want them to be robot like this, which the construction site is already dangerous enough. And we're adding this more powerful, freely moving, rigid robot that will add more safety concerns. So soft robot is a rising trend in robotics area. And one of the critical challenge is how do we estimate the shape of the soft robot, because it has an infinite degree of freedom because you can deform it at anywhere. It can apply, can be adaptive to the environment. So here we use the technology in 5 and enabled something called proprioception, where simply from the images captured within this Baymax toy, the 5 images, we were able to estimate the shape indicated by this color point cloud. And you can compare that with the ground truth captured from another camera. And you see the 2 shape matches exactly. So this video also is another proof of me as a big fan of anime. So this is from that Hero Super, I forgot the name of that movie, but this toy's name is Baymax. Okay.
A quick question. The reason you are doing number 5 is to better estimate the change of the soft robot, and this is for better control, right?
So for number 8, the work that is published right now, we're only doing the shape estimation or state estimation, sensing. The next step of this project is to move on to planning and control.
Okay.
I guess there's only a few. Oh, someone finally asked 3. So number 3 is a work that I did before joining NYU. It is obviously related to self-driving because one of my main job responsibility at Mitsubishi was to investigate deep learning solutions for their self-driving cars. And this work is we input a dash cam image as indicated by this top left corner. We send this image to a neural network, and the network will tell the car different semantic information of the pixels. Some pixels are colored. So we only care about object boundaries because those give us information about where are the places that we can go, where are the places that we cannot. So you see some colors are indicating the boundary between the road and the sidewalk, some between the road and the human, some between the road and the car. All these information will give you, will help the self-driving vehicle to better understand the environment. So imagine we equip the same ability to a autonomous construction equipment, such as a autonomous truck or autonomous excavator. And that's not a dream, by the way. It's already being developed in some startup companies. We will show those later. So imagine equipping those construction equipment with this technology, then they will be able to enjoy the same ability as self-driving vehicles. Someone mentioned number 6. I think I already explained. I guess the only remaining ones are 0, 1, and 4. So I'll explain them one by one. 4 uses the technology in 3, and we use this to localize the cars. So the idea is in urban areas, localizing a vehicle is quite challenging because GPS suffers from this problem called urban canyon. When you have high-rise buildings or sometimes even a big tree, this GPS signal could be blocked, and you can you will find your GPS is giving you crazy command. Right? Once I was driving in Chicago, and that was the first time I was driving there, and my GPS went crazy. Like last second it told me to turn left, and the next second it told me to turn right. I didn't know what to do. So here what we are doing is to use to learn from how humans navigate and localize themselves. Basically, we remember the visual features and we search. As long as we have visited one place for several times, we remember that visual features. And as long as next time you revisit this place, you input your eye sees what you see, and then it queries from your previous visual memory. Then they will. That's how human brains localize ourselves. So using this method, with only images, we can localize a vehicle driving in an urban area without using GPS at all, and it will be more reliable, especially when, especially in New York area, if the car goes into like a tunnel, GPS will definitely not work, and this solution will make it more robust. So you can imagine in a construction site with high-rise buildings, GPS will not work always, will not always work. So this solution could be useful as well.
A quick question, Chen. So for the number 4, my understanding is it recognizes the landmarks, and is that possible for you to also treat it as some kind of network, showing the routes?
Treat the network. So right now what we're doing is using a single image as a query image. In the future, if we use a sequence of image, then it will be able to increase the robustness. I suppose that's what you mean by
yes.
Right. Yes, that's a possibility. Right now, and that ability depends on the reliability of a or localization based on single image. So if you have a better ability for a single image, you automatically get better ability for localization using a sequence of images.
All right, thank you.
Yep. So numbers 0 and 1 are connected. Basically, this research represents the big area in robotics and self-driving named SLAM. It stands for simultaneous localization and mapping, because for a robot or a AR headset like the Microsoft HoloLens, for those devices, in order to provide the functionality, they need to constantly keep track of their own position and orientation in the 3D space as a 6-dimensional vector. So SLAM is a method to enable that without using any other devices in the environment. So these two algorithms is able to help. It was developed seven years ago almost. That enables a handheld camera, RGBD camera, such as Kinect, Microsoft Kinect camera. We use those to localize the camera and so as to localize either the robot or the AR headset. Number one is a method that efficiently extract the planes from the 3D point cloud. It runs on a single core, like a single thread process without any GPU, and it can run on resource constrained devices. This method is patented, and I think it was explored by both Google and Magic Leap because it's useful for the AR headsets as well. So these 9 different videos are to visualize some of the past efforts and ongoing efforts in my lab, and we believe and each of them represents a different route that we are good at, and we hope to keep on working to finally enable the so-called ability as spatial AI. So we want to develop a suite of those methods to create the concept called spatial AI, and using this to enable to realize the autonomous construction robots. I always want to use this Wally robot. I showed it in my PhD defense. This is like one of my dreams. I think in the future, if any construction worker or civil engineering workers, they can have their Wally type of robot companion. That will be very cool. The industry will look much more modern and attract more talent into this field. So with that, I want to keep on talking about introduce the automation and robotics research and current state of the art in the industry, because those are, I think, maybe more related to some of you who aim to get into the industry, maybe related to some of those topics. So the motivation for us to develop automation and robotics in construction is obviously safety. Safety is one of the #1 motivation for us, for researchers and industry to look into this area. So we saw previously the GE building photo where workers are, they need to, from time to time, construction workers need to work in a very harsh environment or very dangerous environment. Of course, at that time, there was no to protect them. Now we have better protections, but still, from time to time, these environments are not ideal, and yet there is not enough. How should I say? There is not enough automated solutions. So in the end, human has to enter. And actually, if you look at the table, safety in construction has been and is still a big issue in this industry. If you look at this table, construction suffers from the largest number of fatalities, occupational fatalities, compared to all other industries, right? It's top 1. Even though the ratio may not be the largest, it's still like among the top 3 or 4, but the absolute quantity is the largest, right? So if our research in robotics for construction can help to reduce even just a few numbers here, I think those are significant, because those are not just numbers. Another motivation for these areas of research is the well-known low labor productivity growth rates, right? I think in your construction, maybe undergrad or grad level courses, your professors must have shown similar curves like this, where they're comparing all the other industries versus the construction. And if you compare the labor productivity curve over the past several decades, this is not changing at all, or even some curve will show it's actually declining. Of course, there are multiple complex reasons for this phenomena. It's not just because of technology, but if we have better technology, such as how robotics is benefiting the manufacturing industry, then we would see better and more faster growth in this labor productivity for this industry. So it's not just in US, in worldwide, if you look at this figure, in UK and Germany, we see similar effect as well. A third motivation for this research is the cost and schedule overruns. This is a figure I took from, I think, McKinsey. Over the next several slides, you will see multiple images from McKinsey. They do the pretty good analysis and to motivate, actually give at least my group a good way to ask for new grants, right? So I think I want to speed up. So with all these existing problems, the industry are facing more and more challenges in the current era. The projects that we're building are more and more complex and larger and larger in scale. And there is a growing demand for the environmentally sensitive construction. And also in many developed areas, we see those shortage of skilled laborers and supervisory staff. So all these, in my opinion, calls for better technology support. Of course, this is not just a technology problem. There's a lot we can do from the management side, but technology basically increases the lower bound, right? Management can help you to do better with existing technology. So my group, and I think our colleagues in this area, aims at raising the lower bound. With better technology, the lower bound can immediately increase. And another figure from McKinsey, which shows construction is among the least digitized industry. It's at here, the same as agriculture. But actually, in agriculture, there are more and more automated solutions, especially if you look at those developed countries like Australia, in the US. They actually have a lot of good automation solutions, unlike in construction. Again, identified by their report, they believe there are 5 different trends or emerging technologies in this area, ranging from high definition surveying and geolocation. We will see several videos like this. And also the next generation 5D beam. I will not talk anything about beam because I think Professor Eric is an expert in that area, and you must have learned a lot already. So I will focus on other technologies. And they also talk about digital collaboration and mobility. This is basically office automation. The same technology being used in other industry can benefit this as well. And the IoT, I myself, my group does not do much in IoT. But I have a nice video to show. In the end, there's this future-proof design and construction. We will give you more concrete examples of those emerging technologies and help to explain. Hopefully, you can see how they are benefiting the industry. This one is to show the first one, the high definition surveying and surveying and mapping technologies. We see GPS, we see photogrammetry, we see LiDAR. You will see 2 quite interesting videos in LiDAR and photogrammetry. They're helping us to get better and more comprehensive, large-scale, more detailed documentation, digital documentation of a job site, right? And if you do this continuously, you actually get a multiple documentations as time goes by that stores the record of how the project evolved from the beginning to the end. Those are due to the use of imaging technologies and laser technologies. This graph is also something I think is quite interesting. The next 2 graphs, along with this one, shows the growth of emerging technologies being used in construction and civil. The dots shows different technologies, and the edges shows the co-occurrence of those technologies. For example, you see 3D modeling and BIM are usually talked discussed together. They showed together in some of those companies using those technologies, and also laser scanning and drone-enabled inspection. We see machine learning with real-time monitoring and control, right? So on and so forth. It's a quite complex diagram, and you can easily find this online, and you can play with it. And I think it's pretty fun and help you to see a bigger picture of how are the technologies being used in the construction area. And this one is, I use it to motivate, I want to encourage students in this area, especially from construction civil, to look into the option of startups. Actually, there are quite a few, I was involved in quite a few construction-related startups serving as consultant or encouraging my students to try to commercialize some of the technologies in my lab. But looking at the in the past, the investment in construction technology has doubled over the past decades. If you compare this to the number of billions of US dollars invested to construction in 2008, it was only 9, but like after 10 years, it doubles, right? So I think that's an encouragement for students, for folks who are interested in exploring these possibilities. And by the way, you don't need to worry if you do not understand all those technologies. I think no one does. The good thing, the important thing is to find the good technology, build a good team, right? And that's also why in my group, it's a multidisciplinary group. We talk with folks at different areas, different domain, and try to foster this growth. This figure shows also the number of transactions versus the technology companies in construction being founded over the past 5 years. I will skip the details. You can easily find out this report from McKinsey. Over the next, I want to quickly show several videos before we finish the presentation. So the state-of-the-art technology is being used not in the lab, but in the industry by startups or by some well-known construction companies, are mainly centered around 2 groups of emerging technologies: the information technology or automation technology. If I had time, I would ask you to define this, but now I think I will just reveal the answer. To me, I define information technology as the technology to help us collect, manipulate, analyze, transmit, and store data or information using computers is one big feature of this technology. The automation technology means a process or procedure is performed with minimum human assistance. If we use those technology to help achieve those technology, we can consider them as automation technologies. And they're more physical, they're less virtual. They means some machine needs to deal with the real world objects, dealing with the real construction work, right? And in the current industry, I listed these technologies that are extensively being discussed, from laser scan, LiDAR, photogrammetry, to machine learning, computer vision, or the buzzword artificial intelligence, and also VR and AR, as well as drones and 3D printing. I group them by their functionality. The first group, it means data collection. They focus on collecting data about either the job site of the construction or like in a factory. The second group means to analyze the data that have been collected, because when you are using automated digital data collection, you easily have a large amount of data that is simply impossible to be examined by human one by one. So you need to have, when you are investing your resource in digital data collection, the next step is to invest in automated analysis, or at least assist, like using those technology to assist your analysis. Once you analyze those data, you need to be able to present them to stakeholders, to non-tech person. And visualization becomes an important tool to connect different parties and different stakeholders. And here, VR and AR is the most important new emerging tools. In the end, the first three categories are just, they're more like information. They don't necessarily need to deal with any physical change of the environment. But in order to really address the safety concerns, safety motivations of these line of research, we need to get our hands dirty. We need to get into the real job site. So we need to automate some of those hard tasks. So here we can see 3D printing, robots, drones flying on the job site. I consider those as automation technologies. So I think I have many videos. I will need to fast forward some of them. So this one, let me turn off the sound. So this one was done by a colleague at NYU, Dr. Deborah Leffer. She actually collected this data of scanned the whole city of Dublin when she was a professor there. And you see the level of detail that can capture. Of course, this is a quite long and tedious process. They basically hire a helicopter company to use that LiDAR and fly it above the city multiple times in order to get the 3D point cloud of the city. But imagine using this technology for a construction site, you immediately get very detailed information, shape information, progress information of the job site. And especially if you're doing linear construction for like road construction, tunnel, so on and so forth, this will be also useful. And you don't need the helicopter now, you can put it on a drone. Another one is the photogrammetry, in which this was done by a famous researcher in our field at UIUC. So basically, using LiDAR is an expensive sensor. Before investing into LiDAR, image is another option. You can use multiple images on the job site to create a 3D point cloud of the job site using the technology called structure from motion, or SLAM. And then what you can do is you can actually overlay the photos that you took with respect to this 3D digital model and see what's going on at that specific date and time on the job site. So this technology is right now being commercialized by this professor, and I think they're in collaboration with Oracle. So this is photogrammetry. Computer vision and machine learning is the backbone technology supporting all these data collection and analysis. Here I'm showing one example related to not immediately to construction, but for transportation. So if you have those surveillance cameras, and with computer vision and machine learning, we can automatically detect all the cars and estimate their speed and track their trajectories. This technology can be used, I think it can play also an important role for job site management. Let me try to. Actually, Microsoft is already doing that.
As our world becomes increasingly digitized, so does our ability to connect with it. Imagine if you could search your surroundings the same way you search the web.
I will lower the volume and talk while this video is talking at the same time. But basically, what's surprising is Microsoft, as a big IT company, usually has no business, not many business in construction except for the Microsoft project. But they are investing resources in technologies related to our industry, and this is to combine the computer vision and deep learning technology for job site surveillance, using all the cameras already installed on the job site, and then use deep neural network to do object detection and retrieval. We can solve quite a few critical problems in the industry, such as facility asset management, facility management. You can imagine using this to search for where a asset was if you cannot find it right now,
wheelchair is
right? You
identified.
can see where it was
that the nurse
used
can
and who was
quickly get the
using, who
patient
was the last
seated
one
and
who touched
safe.
that expensive
This
piece
technology
of
is also
equipment
useful
or
in an
asset.
environment like a construction site.
So VR, of course, we have lots of experts. Actually, Dr. Eric is an expert in this area, so I will skip this and I will move on to the AR. AR stands for Augmented Reality. The difference between the two is we are not in a completely virtual world compared to VR. In AR, we are augmenting virtual information onto the real world through either head-mounted display or like the see-through glasses. Or recently, my lab is developing solutions using projectors to project virtual information directly onto the job site as well for workers, so they don't need to wear any glasses. But this is a technology company named DAQRI. They actually, when they were still a startup, they reached out to us at Michigan to discuss collaborations. And obviously later on, they're collaborating with Microsoft. And you can see through this video a lot of nice, interesting, very useful applications in the industry.
Working in construction, there really is nothing like walking down.
So this is a video from Autodesk. It's talking about Internet of Things. In the interest of time, I will skip it. But this link, you can just search for Internet of Things and Autodesk. You will be able to see this video. It shows the benefits of IoT with construction. So I want to quickly play several videos regarding one of my core research area is to combine mobile robotics with 3D printing. Actually, we have an ongoing project funded by NSF to develop mobile 3D printers that can allow us to print while moving. So here, I want to show everybody what is going on worldwide in this area. People are doing different things, related things such as bricklaying, 3D printing, timber construction, so on and so forth. The bricklaying using automated machines is a technology that is not a dream anymore. Actually, in New York, this is a company, Construction Robotics, is a company in New York State where you can actually rent or buy this machine. And they are, I think, according to my friend, they are already using this machine in Michigan while building a factory for the Ford, the automotive company, to build those factories. So that's an automated bricklaying machine. In the bottom, this video shows a Fast Brick Robotics company, a startup company in Australia, where they're combining this sort of like excavator type of machine that can automate it and accurately lay bricks. Okay, of course there is no reinforcement, there is no motor concrete involved, but it shows the ability. Okay, a more realistic work line of research is 3D printing using robot arms. Here, robot arms means those 6 degree of freedom robot arms being used in typically in car manufacturing industry. And people are repurposing those arms with print head, 3D concrete print head, and then print those complex structures. So one of our biggest enemy in construction is architects, right? Designers. They always want to design those very weird shapes and difficult to be constructed. So using robots, we can make those, we can realize those things more easily. And we see different of those similar works happening worldwide in Europe, in Singapore, in China. The key feature is they have this robot sitting on site and print a concrete structure. Of course, a lot of times the reinforcement is a problem, but researchers are developing different technologies to solve that by using polymer reinforcement, and so on and so forth. Okay. What's different in the research of my lab is we aim to develop similar functionality while putting the robot on a mobile base. So the robot is not limited by the range of this framework, this frame, this gantry, right? Because if you are using this kind of 3D printer, you can never print something that is bigger than this framework. However, if you can imagine install this on a truck and do mobile 3D printing, then the scale and the speed can all be increased drastically. So sorry, did I just skip one? So this is a video from Europe in ETH. What they're doing, again, I'm going to fast forward, but you can easily search for those videos on YouTube. What they're doing is an indoor factory settings where they have this robot that it can automatically pick up timber to perform timber construction. All the nailing, cutting, all those works are done by the robot, and the robot is automatically building this wood frame. Okay, I think these could be a technology of interest to modular and offsite construction, even though right now it's still sitting in the lab. And this is a startup company in California where they're combining self-driving technology with this mini track loaders and achieve automated the job site layout. Right? You can actually see that the technology they're using, I believe, is actually not even as complex as the self-driving cars, because they just need GPS to guide the machine. They don't need the machine to be super safe because they can control the site without any pedestrians walking by. But imagine in the future when multiple vehicles and vehicles with workers. So if in this kind of situation, the vehicle needs to have the ability to detect the person and pause its action. And I don't know whether they are really achieving that or it's just a remote control by now. And this is a startup in Ann Arbor. I think they are based on Ann Arbor, in which they install these 3D laser scanners on a small mini robot and use that to scan a job site, and using the technology similar to what we just discussed, like SLAM, to register all different point clouds together to create a 3D scan of the environment. And then they can do very efficient job site documentation and progress monitoring. This last one is in Japan, and they're actually a company called Komatsu and Skycatch. They're collaborating with NVIDIA to deploy drones in construction site. I will just fly out. Fast forward. I don't think I have enough time to show that. But
you have.
Oh, that. I do? Okay, cool. But anyway, this most of this video was in Japanese, so we don't need to listen to that. The idea is you see this rising trend worldwide, not just in the US, not just in the Europe, everywhere is doing this. So you see this rising trend, and there's a huge need of increasing the safety, the productivity, and lowering the required job skills, traditional job skills, in everywhere. So you may be. I've actually provided a few other examples from the actual more big names in the field, right? Barton Mello, they're already using those drones, reality capture in their projects. I found on their website. You see Skanska. One news shows that they're in Europe. They're commercializing 3D printing, concrete construction 3D printing technology in collaboration with the academia. And also in another news report, they're collaborating and investigating within the company to use AI and image analysis, computer vision to improve the safety and management efficiency of the job site, complex job sites. And before I end, there are a few more examples to motivate you to study more in this field. So I took some time to search on LinkedIn, Glassdoor about job posts related to you, right? If you want to find intern positions in some construction-related projects, you see those keywords: augmented reality, GIS, 3D printing, laser scanning, right? You see point cloud, right? You see transformative technologies, willing to bring in a new transformative technology to the construction industry. You see Skanska, innovative construction solution, Autodesk, construction's technical specialist. So in the end, I want to show this video. I want to show this video as a futuristic hope that in the next 30 years, I think you will be the future technology fans in the field, and hopefully you will promote the adoption of construction robotics technologies and for the future generations. Right? So let's look at this together. actually, in my lab, recently received a grant to develop exoskeletons for workers with upper limb disabilities. So these exoskeletons is also looked at by other university researchers to help construction workers because we have to do a lot of repetitive and tasks. With the help of exoskeleton, we can relieve some of the health issues, health concerns, and also lift more, perform jobs more efficiently. All right, cool. So with that, I will conclude my presentation. I guess the take-home message for everyone is in this big trend, how do you plan for your future career? What kind of new skills do you need? How do you combine that with your existing skill? How do you find your position in this bright new future? I think this is an open question, open-ended question. Everybody, you must have been thinking about already, even before my lecture. But I hope my presentation today can give you some inspiration. And if that's the case, I will be more than happy to see that. Thank you very much.
Thank you so much, Dr. Feng, Dr. Chen Feng. So before you leave, I do have two quick questions for you, very technical question.
Sure.
So the first question is, I really want to hear your opinion in human-robot collaboration. So you talk a lot of automation technology. So if we have some research students doing research in the area of human-robot collaboration. So in your opinion, what can be the good topics for HRC?
That's a very good question. My previous research was not focusing too much about human because I'm always afraid of human. I think it's a very, very difficult subject because humans are not like machine. For machine, I can program them. For human, I cannot, and I have to estimate what they need to do. Actually, one of the projects we're doing right now for that exoskeleton project, what we want to do is to anticipate the human movement and then to provide the needed assistance from the exoskeleton to the people who have upper limb disabilities. And this is a quite challenging task. So I know there are other researchers in the robotics domain looking at HRC, and some of them are focusing on the idea of how to increase the communication, how to perform efficient communication between the machine and the robot. Because in order for the assistant to be usable, this is actually quite important topic. It's maybe easy for human, actually, even though this is already very hard, but still for a human to for a robot to understand what the human is doing and what the human will be performing in the next few milliseconds is still okay. But how do you make sure the human will understand what the robot will do? And if there is a miscommunication from either side, there will be dangerous while they're collaborating with each other. So one possible solution is to completely circumvent the HRC, like soft robot. It's to say, even if the robot is making some mistakes, it's not going to harm the people because it's safe. It's like this balloon-like robot. But of course, I think that you won't see that in the next 30 years. I think that there's a long way to go in that route. But back to HRC, I think one way is the two-way communication. That is an important topic. Yeah, I think actually everything about HRC is about the two-way communication. How do you make sure they understand each other from different modality, audio signal, visual signal from augmented reality? People are actually using AR to project the robot's intention so the human can see. In my group, even though we don't do much on that, but the work that I just mentioned, we use projector. We install a projector to a robot and use that to project the information onto the job site. So the human can can get the information to perform the job, and also understand the intention of the robot from visual information, because visual information is higher dimension and more faster compared to audio and tactile signals. So yeah, but that's my opinion about the HRC.
A quick follow-up question. So my team is also doing a lot of HRC study, and we use ROS plus VR. So VR is the simulation platform, but in order to reproduce the realistic robotic, actions, we use ROS to generate data. So my students discovered that there's a new engine called Physics X version 2 that has a stronger robotic simulation function inside Unity. So I guess my question for you is, if we have existing solution like exchanging data between the two platforms, ROS and Unity, and what is the potential benefits of having everything inside Unity? What is the, of course it's faster, it's more efficient. Let's say that's 1 to 100, we improve from 1 to 100. But what is the 0 to 1, advancements by having this Unity-driven robotic simulation? What's your opinion?
So I myself, I don't know about the Physics X engine. So for Unity, I know the advantage is the simulation, the engine itself, in terms of the 3D simulation, is better than the Gazebo, the ROS simulator. I mean, the visual quality is better if you want to, especially if you want to test something in a realistic environment. The Gazebo visualization, well, it's not real at all. You don't get good ray tracing and rendering. The image you look like, it's like playing first generation Counter-Strike FPS game, right? It's like very low quality. So that could be an issue when you are testing the real reaction of human with the VR. But it's a difficult question, because for Unity, the Unity was not meant to be a robotics simulation software, right? But ROS, Gazebo, those are meant to be a ROS. They have the whole environment set up, all the path planning, all the control, and all those virtual sensing are all there. But for Unity, maybe you need to decide at the beginning what are the functionalities you need, and then check whether the two platforms have support both. And you don't want to discover in the middle of the project, hey, there is some critical function I don't have in Unity, and now because I've already invested so many time resource in this, I have to develop it on my own. That would be something less ideal. For ROS, what you are sure is everything about robotics should be there. If it's not there, probably you won't be able to find it anywhere else. You have to develop it anyway, because everybody, almost all the robotics researchers, not 100%, but at least 80% of them are always trying to, whenever they develop new methods, new tools, they want to make it ROS compliant. But Unity is not necessarily a standard yet.
So I do have some thoughts, and once again, just exchange the ideas and thinking loudly. So you are doing computer vision. I guess the computer vision also relies on high fidelity, visual data. Unity is really good at generating or simulating that kind of visual data. So what do you think if we put a human agent and a simulated robot inside a Unity simulator, that can also benefit AI? Like some things of facial expression, or be robust to different light conditions. If we are able to simulate them in Unity, would that be an additional benefit to not only understanding human behavior, but also improving AI?
Right, that's a good question. Actually, last night I was chatting with a friend of mine who wants to create a startup for synthetic data generation to help AI. So that's definitely one trend, because AI right now, the AI relies on deep learning, and we know deep learning have this data hungry issue, needs to feed it with a lot of data. So synthetic data is definitely one way people are doing. A potential issue of using only synthetic data is the so-called domain difference between the simulated data and the real data. The problem is called scene to real. When you train, when you have an agent, AI agent that is trained on simulated environment, a lot of the times we see the ability is not directly transferable to real world. Actually, before I left Merle, there was the last project I was involved in. We aim to have a robot arm solve a maze problem where you have a sphere, like a little sphere that the goal of that is to move the sphere to the center of the maze by rotating that maze, rotating the different the pose. So the sphere will follow the gravity and eventually go to the center. So we trained this event originally using a simulator in Unreal Engine, not the Unity, but Unreal. It's another one with good graphics, and everything works pretty well in the simulation. But when we want to deploy this on a robot arm to actually show it in real world, nothing works. And that was only 1 month away from demonstrating it to the big boss of the company. So that was one of the issues. So the reason I gave this example is to show the concern of the so-called scene to real adaptation. And this is one of the areas in robotics and machine learning that people are looking at to address. We definitely want to benefit from simulation, but how do we address this gap from the between the simulation and the real world is a big issue. And yeah.
So I guess eventually we need to find a balance, you know, like a Unity and Unreal Engine, you know, these engines are really good at simulation. So like simulating a general, not a realistic, but a close to realistic environment, right?
Right. The rendering quality is very high.
The rendering qualities are better. But the raw system is really good at the functions, you know, like the ability to control a real robot and to talk to different sensors and hardware, right? And those functions are not readily available in the game engines. So it all depends on what are the key research questions we're asking, right? So if the functions are more important to us, maybe we should rely on ROS. But if, you know, answering human behavior change or some critical steps for understanding AR is important, then we can switch to there. But I guess the point is we need to find that balance, right?
Right. And also maybe this is not a binary thing. Like you can try to bridge the two, because ROS is, I think it's an open system. It allows you to talk between different softwares. So you don't need to give up ROS if you choose the other route. Keep in mind that ROS is just it's a suite of softwares that are bundled together by the ROS communication framework. That's why it's called Robot Operating System, ROS. So it's actually, so it's actually possible, I think, to link Unity or Unreal or other, even VR or even Beam with ROS. So actually in that early video I showed in my PhD research that we have this robot arm picking up bricks. In that project, we are linking Rhino with the robot through ROS. And Rhino is definitely not a robotics software. It's a design software. And through the use of Python, we're connecting between different parties, and it's definitely doable.
Thank you.
Yeah.
Any more questions from the class? Sorry, I have been asking all the questions. Any question from the rest of the class? No. All right. So one last request from the class. Can you share the PowerPoint with us?
Sure. I can print it as a PDF and then share it with everyone.
We'll forward it to the class.
No
All
problem.
right. Thank you so much, Chen. You know, I really enjoyed your presentation. Hopefully, we can do it one more time in the future.
Thank you. Sure. And I will also invite you to my class.
Okay, sure. I will definitely do the favor for you as well. Okay, thank you. So let's take a 15-minute break. Let's return at let's say 5:35. All right. Thank you, Chen.
Thank you. Bye. Bye.